Welcome to 4.2 part 2. We're going to work with the scientific notation now. So first thing we're going to do is we're going to convert these numbers into numbers that are in scientific notation. Now remember that scientific notation is of the form m times 10 to the power of m, where m, this big M, is a number between 1 and 10. So to make this a number between 1 and 10, we need to put a decimal right there. So we're going to have 2.8. Now, when we do that, we're moving this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So this is going to be times 10 to the 10th power, and this is that number in scientific notation. Now, to make this a number between 1 and 10, we're going to have to put the decimal between the 6 and the 7, so we have 6.7 times 10 to the... Now, notice, here when we're moving the decimal to the left, to make this in scientific notation, this number is positive. When we move to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have a negative 11. And that's how we're going to move that in scientific notation. Now, moving out of scientific notation, 10 to the 15th power, this is a big number, which means that really what we're going to be doing is we're going to be taking this decimal and moving it to the right 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the decimal's there. Now, all of these turn into placeholders where we have to put zeros. So this number, moving it out of scientific notation back into standard notation, we have 874. Well, two of these of the 15 were to move that over here. Now we have 13 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. And then we can put commas in here if we want. And some more commas. I don't know. It's this really big number. That's what I'm trying to get at here. Now, when we're moving this from scientific notation to standard notation, because we have the negative 9 here, we're going to move the decimal to the left. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have to put our placeholders in. Now notice, if we're moving it to the left 9, one of those was to get over past the 1. So then there's going to be 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 8, 5. That's this number in scientific notation. Now, getting numbers into and out of scientific notation is good, but really what we're doing is we're going to be using these numbers in computational type aspects to find specific things in the field of science, particularly chemistry and physics and biology. So we need to know how to work with these numbers. So here in this next section, we're going to be doing some multiplying and dividing. So when we multiply these, we multiply the things that seem consistent, and we use the rules of exponents. So one thing is this. This is a number in scientific notation. This is a number in scientific notation. When we multiply these, multiply the 8 and the 4. That's 32. Now we multiply the powers of 10. If we have 10 to the power of 6 times 10 to the power of 15, we're multiplying two things with like bases. When we do that, we add the exponents. So 32 times 10 to the 21st power. Now here's the problem with this. This number, 32, is not in scientific notation. So to put this in scientific notation, we have to put the decimal there. So we're moving the decimal place to the left one. When this is moving to the left, this number is getting bigger. So this is 3.2 times 10 to the 22nd power. If we start by multiplying two things in scientific notation, we want to leave them in scientific notation. So that's what we have here. Now here, if we have 3.9 times 10 to the negative 17th times 8 times 10 to the 13th, we want to multiply the numbers. So we have 3.9 times 8. That's going to give us 31.2. Then our 10 to the negative 17th times 10 to the 13th, we have like bases, so we add the exponents. Negative 17 plus 13, so we have times 10 to the negative 4th power. Now, once again, this number right here, 31.2, is not a number between 1 and 10, so we have to move the decimal over here 1. So we have 3.12. When this decimal is moving to the left, the number is getting bigger, so this increases by 1. So this is times 10 to the negative 3rd power. Now, when we're dividing, same thing we do as we did before. Like when we're up here, we're multiplying the numbers and then considering the powers of 10. Same thing here. Really, we could think of this as 3 times 10 to the 6th over 6 times 10 to the 9th. So here, if we have 3 divided by 6, well, 3 divided by 6, that is going to give us 1/2, or 0.5. Then if we have 10 to the 6th divided by 10 to the 9th, remember that we subtract subtract the power of the denominator from the numerator, so this is going to be times 10 to the 6 minus 9. So we have 0.5 times 10 to the negative third. Now, once again, we've done the division here, but 0.5, this is not between 1 and 10. So we have to move this decimal over here. When we're moving the decimal to the right, this number is getting smaller. So moving this into a number that's between 1 and 10, this is going to be 5 times 10 to the getting smaller by 1. When we subtract 1 from this, negative fourth. So 5 times 10 to the negative fourth is that. This last one over here, we have 3.6 times 10 to the 22nd divided by 9 times 10 to the negative fifth. Well, we're going to divide these. Once again, so 3.6 divided by 9 ends up being 0.4. And then here, because we're dividing these powers of 10, we're going to subtract the power of the denominator off the numerator. So this is times 10 to the 22 minus negative 5. So a couple things. Here, 0.4 is not between 1 and 10, so we're going to have to fix that to get this in scientific notation. So we'll do that in a second. So we have 0.4 times 10 to the here. 22 minus negative 5 is really plus 5, which is 27. Now, when we move this over, we have 4 times 10 to. This is moving to the right, so this is getting smaller by 1. So 4 times 10 to the 26th. So that's how we move into and out of scientific notation, and this is how we do computations and calculations with scientific notation. So hopefully that makes sense. We'll see you next time for some polynomials.